No, it don't! No, it don't!
1. Here's what the Rolle's theorem states. Now, in order for you to do the Rolle's theorem, I'm going to teach you the first theorem. It's a pretty easy theorem. It's really based on common sense. Rolle's theorem. In order for you to understand this theorem, I'm going to start with a basic diagram. Y equals to x squared. Most of you can quickly sketch this graph. Okay. So if I were to look at the y equals to x squared, the graph looks something like this. It's a simple parabola. Okay. It keeps on going. And here's what the Rolle's theorem states. It's a very simple concept, says Mr. That's a pretty easy concept. I'm going to choose a point A. We'll call this point A somewhere. Okay? Very, very simple concept. I'm going to go A, and we'll call this point F of A. I'm going to choose another point anywhere along this graph you want. We'll call this point B. We'll call this F of B. And here's what the theorem states. They're saying this. If Rolle's theorem, correct conditions, you need to have these conditions satisfied before you can apply Rolle's theorem. The first condition, number 1, F is continuous. There's that word continuous, which I taught to you last time. There's 3 conditions for continuity. By the way, does anyone remember the 3 conditions for continuity? There should be a limit. That's 1. Has to be defined. You're close. The f of a has equal to limit as x approaches a. So they must exist in the closed interval on the closed interval a, b. Notice I'm using the word closed. If it's open, it can't be done. It has to be closed. 2. F is differentiable. Differentiable, which means I can find the derivative, which means the slope of the tangent line exists. F is differentiable on the open interval. A, B. So when I take the derivative, I don't need to use the endpoints. Now I just need to know that it's differentiable, which means I can take the slope of it. And finally, here's 3. F of A equals to F of B. So in my diagram, I have a continuous graph. Check. I'm just checking each one. This graph is continuous. This graph, I can find the slope of any point from A to B, which is check. And look at this. There's a point somewhere where such that f of A equals to f of B. Check. If these 3 conditions are met, what Rolle says is this. There's a C. Then there is a C. In A, so somewhere between A and B, there's a C, such that f prime of C equals to 0. What? Sounds like a mess. What the heck? So which means, guys, your job is to find on this graph where is that C. If I have 2 y points that are, here's what it says in plain English. This sounds really technical, but in plain English it says this. If you have 2 y values that are the same in any given curve that is continuous, there means there's a point C somewhere that have a horizontal slope for the tangent, which is here. There's my C. Okay? Sorry? Oh, wait. In plain English? Yes. In plain English means this. If you have 2 y points that are the same, see? That means there's a point C this point, mystery point C, somewhere in between A and B, such that the slope of the tangent line will be 0. We don't know where. I'm just saying there is a point C. Some of you say, no, that's impossible. I'm going to draw the most weirdest graph in the world to prove you wrong. So here we go. Let's draw this weird point. I want you to choose any 2 points that have the same y value, and I bet you $100 there is a curve slope that is going to be 0. Go. If I were to choose anywhere, let's say I choose this point and this point, which means somewhere along this nice continuous curve, see, notice it has to be continuous, and I better be able to find the derivative. There has to be a point C. Well, in this case, there is a point C. The point C lies right here. That is called Rolle's theorem. It's a very simple theorem. And his theorem, some would say, hey, that's pretty clever. I wish I had came up with that. And he just came up with that and he became famous. So there's a lot of things in math that are yet not discovered. So one day, if you discover something new, you can call it your own theorem. And you can name whatever you like. And this person's name was Rolle's, and that's how he came up with Rolle's theorem. And there's actually one, try next one. This is called the mean value theorem. Mean value theorem. Again, in order for me to explain this theorem, I need to start with a graph. Because it's super duper confusing if I show you what it means. Actually, I'm going to write down what it is first. And let's see if you can figure it out. Okay, here's what a mean value theorem states. Again, conditions. In order for you to have a mean value theorem, you need to have these conditions met. If these conditions are not met, you cannot apply the mean value theorem. 1. And the mean value theorem is actually built on the Rolle's theorem. It says f is continuous. There's that word again. Continuous. On the closed interval. A, B. Okay, same thing as Rolle's. So this theorem is actually an extension of Rolle's theorem. 2. F is differentiable. On the open interval. A, B. Now, if these 2 conditions is met, see, the beauty of this is there's only 2. Then there is a number C in AB such that f prime of C equals to FB minus FA over B minus A. That is actually the mean value theorem. Most of you will understand this concept, but when it comes to this and say, Mr. what the heck is this talking about? Does anyone actually know what this is actually saying? It's actually based on that, yeah. It's actually slope. And to show you this, again, it's really hard to show you based on numbers. So this is why reading the text alone is not enough. You need a picture of how this is explained. I'm going to start with a simple graph. Y equals to, let's go back to my classic, x squared. Okay. Go ahead, draw on your graph. Y equals x squared. Now, I know that this is continuous. I know that I can differentiate it. So we'll call this A, and we'll call this B. I want you to choose any point for A you want, so I will call this A. And you can choose any point along here. I don't have to be here. Guys, choose any point along here and we'll call that B. You choose. It doesn't have to be there. For example, let's call this point B. Notice it's not the same anymore. Okay. What this is saying is this. If I were to connect, draw a secant line, connect, all the way through. Okay. What mean value theorem says is this. That means there's a point somewhere in between A and B such that the slope of the tangent line will be parallel to this line. So this line is right here. So would you agree the formula for slope of this line is given by FB minus FA over B minus A. So this is what this is referring to right here. The slope of the secant line. Which means there's a point somewhere along here such that the slope, C, will be parallel to this line. And again, I want you to guess where your C line is going to be. This is where I'm going to play the guessing. I'm going to say maybe my C is here. Yep. Because this point may looks like, if I were to draw a tangent line, it looks like it's parallel. Well, my tangent line didn't work properly. We'll just imagine that it worked. See, ta-da! It says this. So here is slope of tangent line. In English, what this means is this. If I have a secant line connecting anywhere from A to B, that means there's a point C somewhere on this curve. Okay, here's a point C. That will have the same slope no matter what happens. And for you to understand this, let's draw another example. Let's go back to my fancy little... And you actually can do this on your own. Doot, doot. Choose any point A, any point B. And then I want you to go ahead drawing your secant line and then find your mystery point C. I bet you it will work all the time. Go. So let's say I'm going to choose this point as A. Where should I want my A to be? Let's say this is A. Okay? Here's my A value. Doot. Let's say this is B. Now we'll call B. We'll call B somewhere here. Yeah, we'll call this B. B is right here. If I were to connect the line from A to B, oh, this is a bad line. Let me draw it again. There's a line through A to B. And again, it should look. There's a point somewhere in this region, C, such that the slope of the tangent line will be exactly the same as that. That's called the mean value theorem. Now, problem is, where? Well, I'm going to say, in order for me to have a tangent line that looks something like that, it may be right around here. Yeah, maybe right around here. We'll call this point C. Because if I were to draw this tangent line of this, nope, that's not a bit off. My C would be somewhere in there such that the slope will be the same. I'm just figuring out how my C would look like. Would be here somewhere. Yeah, C would be somewhere around here. Because the slope of tangent line would look something like that. See? There's my C value right there. Always case. That's the mean value theorem. Now somebody say, how do you use this in real life? Here, would you agree this is called average velocity? Because your slope is actually something called the average. This is called the instantaneous velocity. Instantaneous. Yeah, I can't spell these days. This is your instantaneous velocity. Here's how you apply this in real life. It goes to a real example that I do every day. I'm going to pause it. I'm going to load up something. Here's your question, guys. Example 1. In the pause, Example 1. The distance from home to work is the actual distance from home to work is this. So I'm going to load up a Google map. This is my house right here. I actually hid the address of it so you can't see it. All the way to Matheson. It is 20.8 kilometers, and according to Google Map, it takes me 39 minutes to get to work every day. True story, every day to get to work.
How long does it take you, Mela?
That's about the exact same time. My question to you is this. Was I speeding at any point along the trip? Explain using math. Explain using the mean value theorem. So here's my house. Actually, I can show you my house on here. Actually, the screen clipping of Google Map. Whoop, sorry. It has the address. So there's the house of my house where I live. Question is, was I speeding? So to get home every day, it takes 20.8 kilometers going to Google Map, and time is 39 minutes. My question to you is, explain using the mean value theorem, was I speeding at any point during the trip? And this is what police use, by the way. They actually use the mean value theorem to catch you. They're like, wait, let me grab my TI-83 out and I will prove you wrong. Before they write you a ticket, they say, let me grab my TI-83 out, and they will do the mean value theorem. So question is, was I speeding any point? I'm going to just show you that map again. Wrong map, right there. There's a map. There's that map. So the distance from here, oh, it just disappeared, to there, well, it kind of disappeared, is, my question is, was I speeding? So in order to do this question, I got to figure out my average velocity. Because would you agree I need to figure out average velocity? If I know average velocity, let's calculate my average velocity first, guys. Go. How fast was I traveling? No. I took there's no highway driving, just simple according to Google Map. I could have chose a highway route, but then I want to use more practical one. 0. What? No, kilometers per hour. Because when you calculate the speeding, cops do not pay you to say, hey, you're traveling 2 kilometers per minute over speed limit. No. 15 meters per second, please. Velocity is in terms of kilometers per hour. So, which is equal to 20.8 kilometers over. Here comes the fun part. What is it? What goes on the bottom? What? 0.65? How do you get 0.65? Hi. Say 0.65 hours. Go ahead, punch in, and what do you get? 32? 32 kilometers per hour. So in other words, I'm driving at 30. Anyone know drivers here? What's the speed limit, by the way? On average, it's around 50. It is actually 50. Now, you can go above 10 and they forgive you, but so on, so on. So was I speeding? The answer is no, according to this. But I'm going to show you, here's what happens. What if I were to cut this down? What if I were to give you this 20.8 kilometers in 20 minutes? That's the fastest I ever gone to school. That's the fastest. Let's say it's middle of the night. There's no cars in the road because there's a And I had to meet that. Okay. So my velocity is equal to 20.8 over 0.65, which gives me, what is it? 62.4 kilometers per hour. So here's the catch. This is my average velocity. But 20.8 over 0.65. Okay. This is on the bottom. So wait, hang on. Let me do this calculator. So 20.8 divided by 0.65. Wait, sorry. Oh, no, I changed it. Oh, sorry. This is not correct. This is, what was this? What? 0.33. So, which means this average velocity, but according to the mean value theorem, this is continuous. There is a point somewhere. So what this says is this. According to the mean value theorem, see, this is average. It doesn't mean I'm traveling at this all the time, but according to the mean value theorem, there's a point in time. There's a point in time when I am traveling at this speed. So if a cop says, well, if you're going this much, I bet you there's a point in time, and you know what? He just used calculus to bust you. Point, I'm traveling at this speed. Okay. That's. So if I were to draw this out and show you what it actually looks like. So let's draw the map again. Here's A. Let's say here's B. And the average velocity is here. And let's say, which means somewhere along here C, we'll call C. Somewhere in between, I have to be traveling at the same speed as the average velocity. That is the average mean value theorem. Your work. I'm going to give you one more quick question, and then I'm going to give you some work to do. Find C. That satisfies the mean value theorem. Satisfies the MVT. So here's your next question. What if I give you this? Y equals to x squared plus 1 from -2 to 1. So you notice I'm using closed interval. Find C that satisfies the MVT. In order for you to do this, I need to know what the average, what the slope is from -2 to 1. So I'm going to quickly do this to show you. So it would be f of b minus f of a over b minus a. So which gives you 2 minus -2 squared plus 1 all over 3. Okay. This is that stuff right there. 2? Because I subbed in b to here. 1 plus 1 is 2. So this becomes 4 plus 1 is 5. 2 minus 5 is -3. So this is -3 over 3. Which means my slope is -1. That's the slope. And what the mean value theorem says is this. If I were to take the derivative of this, or I find the tangent, y prime equals to 2x. That means there's a point C somewhere such that this must equal to -1. And in this case, x equals to -1 over 2. That's what the mean value theorem states. It means there's a point somewhere that it has to be the same. So your work will be a package. And you're gonna do every other question on this package. So you can do, I will do the even questions only. Even. And that's it for today.